If you've ever switched on a light, charged your phone, or plugged in your laptop, you've relied on copper, even if you've never seen it. It's the silent hero inside every wire and circuit, carrying electricity with ease and disappearing behind plastic and walls. But here's something most people don't know. Almost half of all the copper we use today isn't mined fresh from the earth. It's recycled. That means the wires running through your home could have once been part of an old train, a demolished skyscraper, or a bundle of cables buried beneath a city decades ago. Copper is one of the few materials that can be used, melted, and reused again and again without losing its quality. It doesn't weaken. It doesn't rust away. It's practically immortal. But that raises a fascinating question. How exactly do you take millions of feet of old, tangled, dirty copper wire and turn it back into bright, pure metal? To find the answer, we're heading inside the massive, roaring factories where old wires get a second life. It's a story of fire, precision, and surprising beauty. The hidden art of copper recycling. The hidden treasure inside our trash. The story starts long before the factory floor. It begins when something stops working. A fridge, a car, a building that's being torn down. Inside all of it runs copper, miles of it, hidden like veins under skin. When those machines and structures reach the end of their lives, their wires are pulled out, stripped, or sometimes just cut and tossed aside. In scrapyards around the world, piles of cables and electrical cords stack up like tangled snakes, thick, heavy, and covered in dust. Most people would see junk, but for recycling companies, it's gold. Because while copper might not shine like the real thing, it's just as valuable. A single ton of pure copper can sell for thousands of dollars. And in an age when mining is expensive and environmentally damaging, recycling it is a win for both business and the planet. Collectors and scrapyards become the first stop in the chain. They buy old wires by weight, sort them roughly, and compress them into huge bales. Some are clean copper stripped of insulation, shiny and almost ready to melt. Others are still wrapped in thick layers of rubber or plastic waiting to be processed. These bales travel to the recycling factories, vast, noisy facilities that run day and night, and inside them, old copper begins its transformation. Breaking down the old to make the new. The first thing that happens when those bales arrive isn't fire or melting, it's sorting, the quiet, careful prelude before the chaos. Workers and machines team up to separate what's truly copper from what's not. At first glance, it all looks similar. Reddish wires, dull cables, bits of metal and plastic. But not all wires are equal. Some contain aluminum, others steel cores, and mixing them would ruin the purity of the final batch. In some factories, high-tech scanners read the metal's surface chemistry in milliseconds, identifying what's copper and what's an imposter. In others, experienced hands do it by sight and feel. A quick flick of the wrist, a glance at the color, and they just know. Once the pure copper wire piles are ready, it's time for destruction. The wires are fed into giant shredding machines, the kind of equipment that could chew up a bicycle without breaking a sweat. As the blades spin, you hear a deep mechanical growl, the sound of decades of use being ground away. Long cables turn into small fragments in seconds. The air fills with the smell of warm rubber as the insulation breaks apart. By the time the copper leaves the shredder, it's no longer wire. It's a rough mix of chopped up plastic, bits of rubber, and small metallic pieces. It looks chaotic, but hidden inside that pile are thousands of dollars worth of copper waiting to be rescued. The next challenge? Getting the metal out. The art of separation. Imagine trying to pick copper out of a mountain of shredded wire by hand. Impossible, right? Factories solve that problem using a combination of air, magnets, and gravity, all working together like an orchestra. First, the shredded material passes through magnetic separators that pull out any iron or steel that might have sneaked in. You can hear the clank of metal as it's yanked away. What remains drops onto vibrating conveyor tables where heavier bits, the copper, naturally move one way while the lighter plastic shifts the other. In some setups, air jets shoot across the line, blowing away insulation while the copper, heavier and denser, stays put. It's mesmerizing to watch, a storm of color and motion, with bright copper flashes glinting as they tumble down the line. By the end of this stage, the copper emerges as tiny pure granules, often called chops. They're warm, metallic, and surprisingly beautiful up close. small enough to pour through your fingers like sand, yet still unmistakably metal. Those copper chops are the real treasure, clean, concentrated, and ready to melt. From scrap to molten metal. Now comes the dramatic part: fire. The copper chops are shoveled or vacuum fed into huge furnaces that can reach temperatures of more than 1,000 degrees Celsius. It's the kind of heat that turns solid metal into liquid fire. As the furnace roars to life, the chopped copper begins to glow, red, orange, then white hot, until it collapses into a pool of molten metal that moves like thick honey. Standing near it, you can feel the heat from meters away, a wave that blurs the air and makes the walls shimmer. But melting isn't just about heat, it's about chemistry. Even pure copper carries tiny traces of dirt, plastic, or other metals. To remove them, operators add special compounds called fluxes that help separate impurities. They rise to the surface and form a crust that's skimmed off, leaving behind pure liquid copper. It's strangely beautiful, glowing like lava, alive with motion, almost hypnotic. Once the copper is clean, it's poured into molds to cool. The result is something called a copper anode, a large, heavy slab that looks more like an artifact than a piece of metal. But its journey isn't done. Before it can become wire again, it has to be purified even further. Electrolytic refining, electricity cleaning electricity's metal. Copper might be one of the most conductive materials on the planet, but to reach that level of performance, it needs to be perfectly pure, 99.99% pure to be exact. That's where electrolytic refining comes in, a process that sounds complicated but works on a simple principle. Electricity can clean itself. Here's how it works. Those solid copper anodes are hung in giant tanks filled with a bluish liquid, a solution of copper sulfate and acid. Between them are thin sheets of pure copper called cathodes. When an electric current runs through the tank, copper atoms leave the anode, float through the liquid, and attach themselves to the cathode. Slowly, atom by atom, the cathode grows thicker, forming new layers of ultra-pure copper. It's science and art combined, invisible forces rearranging matter, building perfection one molecule at a time. The impurities, things like nickel or silver, fall to the bottom as a kind of metallic mud called anode slime. Believe it or not, that sludge is valuable too. It often contains traces of precious metals like gold and platinum, which are later recovered separately. After several days, the process is complete. The cathodes are lifted out of the tanks, each one a gleaming sheet of nearly flawless copper, smooth, solid, and shining like a mirror. These sheets are then melted down again and cast into thick rods or bars, called billets, ready to be drawn back into wire. It's a perfect loop. Scrap becomes melt, melt becomes sheet, sheet becomes wire again. Drawing it all back together. To turn those heavy copper billets into thin, flexible wire, factories use a process called drawing. It's simple in concept, but mind-blowing to watch. The billets are reheated until they're soft, then pulled through a series of smaller and smaller holes, each one shaving the diameter down bit by bit. The copper stretches, thins, and lengthens hundreds of meters, then kilometers. By the end, what started as a thick rod is now a hair-thin thread of shining copper, ready to be wound onto spools the size of tires. In one factory run, a single spool can hold miles of wire, enough to circle a city block. It's hard not to think about where that wire will go next. Maybe into new homes, new cars, or wind turbines spinning on the coast. Maybe it'll power something that hasn't even been invented yet. Copper doesn't have an end, it just changes form. When those miles of new copper wire roll off the final spools, it's hard to believe they were once a tangled mess of discarded cables. Each strand shines with that distinct reddish gold glow, warm, clean, and almost alive under the light. But before any of it leaves the factory, every inch has to prove it's worthy of a second life. Because when it comes to electricity, almost perfect isn't good enough. Quality control, the purity test. In the next section of the plant, precision replaces chaos. Gone are the sounds of shredders and furnaces. Here, the air hums quietly with machines testing, measuring, and verifying the quality of the recycled copper. Technicians cut small samples from the newly drawn wire and feed them into spectrometers, which are high-tech devices that shoot light or X-rays through the metal to measure purity down to the atom. The goal is 99.99% copper, no less. Even a fraction of a percent off could change how it conducts electricity. Nearby, tensile testing machines stretch pieces of wire until they snap, measuring how much force it takes. The data appears instantly on digital screens. Strength, flexibility, elongation, all must meet strict global standards. If a batch falls short, it doesn't get thrown away. It goes back into the system, remelted and refined again until it's perfect. Recycling isn't just about reusing. It's about making sure what's reused is just as good as the original. The final inspection is visual. Workers wearing gloves inspect the spools as they spin slowly on rollers. They're looking for imperfections, scratches, dull spots, or uneven color. Copper, at its purest, has a kind of glow. Not shiny like gold, but deep and steady, the color of warmth itself. Once it passes every test, the wire is coated or insulated, depending on its destination. Some will be covered in colorful plastic sleeves for electrical use, others left bare for industrial cables or bus bars. Then it's packed, labeled, and loaded onto pallets ready for shipping. What was once waste is now reborn, bright, valuable, and ready to carry energy again. The global journey of recycled copper. From here, the copper begins another adventure. Trucks and ships carry it to factories that turn it into motors, transformers, or intricate electronics. In another corner of the world, it might become the wiring for a new apartment complex. Some of it even ends up back in renewable energy systems, in the coils of wind turbines or the circuits of solar panels. It's poetic, really. Copper that once powered an old coal plant might now be channeling the energy of the sun. Every year, around 9 million tons of copper are recycled worldwide, enough to wrap around the Earth more than 30 times if stretched into a single strand of wire. And that number keeps growing because we've realized something important. Copper isn't disposable, it's cyclical. Mining new copper requires huge amounts of energy, blasting, and chemical processing. Recycling it, on the other hand, uses up to 85% less energy and produces far fewer emissions. That's why copper is sometimes called the green metal, not just for its color when it oxidizes, but for its role in sustainable manufacturing. Innovation and sustainability. Inside modern recycling plants, innovation never stops. One of the biggest challenges is dealing with insulation. That is, all that plastic and rubber coating around wires. In older factories, it was often burned off, releasing harmful fumes. Today, advanced systems use mechanical separation and cryogenic technology, which just means freezing the insulation until it becomes brittle, then breaking it off cleanly without any burning at all. The removed plastic isn't just wasted either. Many plants now recycle it into pellets used for flooring, pipes, or even car interiors. It's a closed loop, nothing truly wasted, everything finding a new purpose. Even the heat from the furnaces gets repurposed. Some facilities pipe it through the building to power heating systems or pre-dry new scrap. Others feed it back into local energy grids. Every bit of efficiency adds up, especially when you're melting hundreds of tons of metal every day. And it's not just about machines. The human side of recycling, the collectors, sorters, technicians, and engineers, plays just as vital a role. Their expertise is what keeps the process safe, accurate, and ethical. In many developing regions, small-scale recyclers have long been the backbone of this system, collecting scrap by hand and preventing mountains of waste from ending up in landfills. More global partnerships are now working to formalize and support them, offering better pay, safer working conditions, and access to cleaner equipment. Because when you think about it, recycling copper isn't just an industrial process. It's a collaboration between people, technology, and nature. The surprising value of copper's longevity. What makes copper special isn't just how efficiently it carries electricity, but how endlessly it can be reused. Unlike plastic, which breaks down, or steel, which can lose strength, copper never wears out. Once it's refined, it can stay in circulation for centuries. Scientists estimate that more than 80% of all copper ever mined in history is still being used today, which is mind-blowing. Some of the copper in your phone might have been part of a Victorian telegraph line. Some could have once powered the first electric streetlights of the 1800s. Every recycling cycle writes a new chapter in the same story. One metal, infinite lives. It's why copper is often called the eternal element in industrial circles. It doesn't die, it just returns to the furnace, gets reborn, and starts again. A day inside the furnace. If you stand on the factory floor during a melt, you can feel that continuity in the air. The furnaces roar like living beasts, glowing orange from the inside. Forklifts move rhythmically, feeding chopped copper into fiery mouths. Streams of molten metal flow like rivers of light, pouring into molds that spark and smoke as they cool. There's no wasted motion. Every second counts. Technicians in heat-resistant suits monitor gauges, adjusting temperature and flow with the precision of surgeons. The rhythm is steady, practiced, almost hypnotic. Then comes the cooling stage. As the copper solidifies, it shifts color, from blinding orange to deep cherry red, then to the familiar metallic brown. The air smells faintly of ozone and heat. The sound of ticking metal fills the space as the bars cool and contract. Each ingot that emerges is stamped, tagged, and rolled away, ready to start another journey. Watching it, you can't help but feel like you're witnessing a kind of rebirth. Something discarded and forgotten becoming useful again, cleaner, stronger, and ready for another century of service. The next generation of copper recycling. Technology is pushing copper recycling even further. New automated systems use artificial intelligence and computer vision to identify copper scrap with astonishing precision, separating materials in real time. Some research labs are experimenting with electrochemical recycling, a low-temperature process that can recover copper from electronic waste using a fraction of the energy traditional methods require. In Japan and parts of Europe, urban mining is becoming a big deal, recovering copper and other metals directly from discarded electronics. A ton of old circuit boards can contain more copper than a ton of ore pulled from the ground. It's faster, cleaner, and much more sustainable. Even the wiring in electric vehicles, which is expected to multiply as EV adoption grows, is now being designed with recycling in mind. Flexible insulation, easy disassembly, and standardized materials make it simpler to reclaim copper at the end of a car's life. Every new invention, every design tweak, feeds into the same idea. What we make should eventually find its way back home. Why it all matters. Copper recycling isn't glamorous. There are no glossy showrooms or sleek packaging, no logos or brands. But it's one of the quiet backbones of modern civilization. Without it, the world would drown in electrical waste and depend far more on destructive mining. Recycling copper saves energy, cuts emissions, and keeps essential materials in circulation. It's the reason cities can grow sustainably, renewable energy can expand, and the devices we rely on can keep getting built without running the planet dry. It's a simple process, but its impact is profound, transforming what's thrown away into the lifeblood of the next generation of technology. So the next time you plug in a charger or flick on a light, take a second to think about the journey behind that simple spark. The wire carrying that current might have lived a dozen different lives. In a ship, a radio tower, a factory, or a street light. It's been melted, refined, and reshaped countless times. Copper doesn't just conduct electricity, it conducts history. It connects generations of builders, engineers, and dreamers. It reminds us that progress doesn't always mean creating something new. Sometimes it means reimagining what already exists. From the scrapyards of forgotten machines to the glowing furnaces of modern recycling plants, copper's story never really ends. It just loops back, stronger each time. And that's the beauty of it. In a world obsessed with the new, copper quietly proves that rebirth can be even more powerful than creation. If you enjoyed uncovering the secret life of copper, hit that like button, subscribe, and turn on notifications because we've got plenty more stories coming your way about how the world's most ordinary things are made extraordinary.